Hi, hello everyone. A big hi to all my dear Vachalo. And if you are someone who is seeing me for the very first time, this is Ameer, your physics educator at Unacademy, and welcome to another beautiful session. Or let's make the session so beautiful, right? So tell me what we are gonna do in today's session. Array, this is a very special session because the chapter wave optics, because this chapter wave optics is known to many of you that hardest chapter of the part 2 physics, right? But after this particular revision session, you all are gonna say the wave optics is too easy. So let's make the revision of wave optics chapter in 1 hour. I hope you all are ready. So tell me who all are you ready with a simple hi, and also tell me how are you all doing here in this chat box. Every one of you with full josh and with full energy I want. Hi Bhumi, hi Vepu, Jia, Evelyn. अरे मैं तो बिल्कुल बढ़िया Evelyn. Thank you so much. मेरा दिन भी बढ़िया था. And I'm also excited. Weekends are coming, right? Saturday, Sunday. So I'm also excited. What is going to come, right? Okay. What all plans I have to make with my friends? ठीक है. Fine. Okay. Hi Sudeep. Then we have Bhumi, Jia, Shweta, Swati, Ganesham, Study Future. Okay, so we have so many beautiful and amazing students here. So everyone, once again, welcome to this class. So if any one of you is seeing me for the very first time, dekh a bit of introduction about myself is given here on the screen. What all you can see? I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board student. I'm a beta graduate from NIT Calicut in mechanical engineering. And one more thing, all my regular students already know that. If anyone is new here, बच्चे लोग I'm from Kerala. ठीक है, I'm not so good with the language of Hindi, लेकिन मैं थोड़ा थोड़ा पढ़ रहा हूँ आजकल. ठीक है, बहुत सारा improvement हो गया, but it's not so good so that I explain the concepts of physics. So what we'll be doing is we'll have all the explanations in English itself. ठीक है, we'll keep to that. And बीच में थोड़ा थोड़ा हिंदी में भी बातें करेगा. Fine. Moving on, देख ले. If you don't want to miss the live classes from your favorite teachers of Unacademy, you can be a part of the Telegram channel. The link is given here and also in the description box. Okay. देख ले, I will just show you the timetable for this particular week. As you all know, today it's over and we are having the last class of this particular week, which is wave optics. And next class, those who don't know, I'll just write it down. Next class for us will be on. कब है बोल दे बच्चा लोग. When is our next class? Is it Saturday? Is it Sunday? नहीं. We have our next class on Monday. Okay, we'll be having our next class on Monday. At what time? At same time, 8 p.m. ठीक है. And are we going to continue with wave optics? अरे बिल्कुल नहीं. नया chapter we are going to start. Which one? Modern physics. So be prepared for that. Be prepared to start this new chapter with me. Okay, so we all will be seeing Monday again after this class because we have to start with that beautiful chapter of modern physics. And I forgot to explain you Bugs Bounty kya hai in between. Array, Bugs Bounty, it's an amazing much which can help you to get lot much of prizes. What do you all have to do? Array, just go to the description. There you'll find a form. Fill the form. If you are finding any inappropriate content in the videos uploaded by Unacademy, if it's valid, बहुत सारा. ठीक है, you'll get so much of prices. मेरा चलो बहुत सारा prices wait कर रहे हैं आप लोगों को. देख ले. Unacademy Combat scholarship test is also waiting for you all. If you haven't written बच्चा लोग, I will say that you have missed a lot much of things है ना in your life because so much of benefits are there for this Unacademy Combat scholarship test. Shall I start from the beginning? देख ले. If you are one among the person of rank 1 to 3, what all are you going to get? Is it some certificate where Unacademy is written? No. Gold medal मिल जाएगा. अरे gold medal, you know how much worthy this gold medal is, है ना? At least the metal gold, how much pricey it is nowadays, you all know. Second rank silver medal, rank 3 bronze medal. We haven't finished. देख ले, you will also be given for 1 year of free Unacademy subscription. Others, don't worry. You people are also going to get some scholarship if you want to join and if you want to be a part of Unacademy family. Then one more thing, just like icing on the cake, that the registration to this, if you want to write this exam, it's completely free. It's free of cost. You don't want to be a plus member, ठीक है? You don't want to be an iconic subscriber, कुछ भी नहीं होना चाहिए. You can just put this code है ना हमारा AMB10 and you can get enrolled for this scholarship test completely for free. ये code use कर ले AMB10 हमारा code है, ठीक है? The entire code for our physics family, use it and be a part of this scholarship test. We are moving on. Now before we start with the session है ना, I just want to tell to all my बच्चा लोग क्या है, अरे share कर ले, ठीक है? Share to all your friends so that together we can learn this topic of wave optics, right? ठीक है? Why we alone have to learn? Let's learn it together, because as the number of people increases, the happiness increases. That's what my motto is, right? Because I love to have a big group of people here. So everyone, share the class to all your friends, okay? And tell them that Bhaiya has started the revision of wave optics. Ask them to come as soon as possible. So Ganesh, Yashaswini, Bhumi, Preeti, Jia, Captain, Mithilesh, Evelyn, okay? Just do it as soon as possible. In the meanwhile, if anyone is new to your Unacademy platform, I'll tell you what all you guys are already missing if you are not a part of the Unacademy Plus subscription platform. Shall I tell you? ठीक है, देख ले. We all are learning through YouTube, right, nowadays? Yes, it's an awesome thing. I do approve of it. But what you all are lacking, because there are some students who would love to have a personal mentoring, a personal touch or a personal guidance directly from their educators, right? They'll feel so more confident when the educator is right behind them to correct their mistakes. So this can happen once you're a part of Unacademy Plus subscription, because there we have the live chats. Okay, there we have the question tab where you can upload your doubts and clear it on the spot whenever a class is happening. More than that, if you're still, your doubt is not cleared, in the app itself, during the live session, you can call your educator, talk to him, get your doubt resolved on the spot. Matlab, zero doubts will be left with you once a chapter is complete or once you deal with an educator in the platform. What else you need if you are learning something, hai na? Or top educators of the country will be there to teach you. Because of their high experience profile, they will be even able to tell you what all examination pattern you should be expecting, what all questions you should be doing so that you can make the best preparations for the term 2, right? Okay, you just follow them. Obviously, you will ace in all the competitive examination you write. That is pakka. Second thing, you can get into the colleges which are you dreaming about, whether it is engineering, medical or any field let it be, right? Then study material, practice test, live test series, everything is going to be there to make you super confident. Now if you go for 12 months, it will cost you 1,250. Now if you need 10% of discount, just remember these 5 things, which is A, M, B, 10. Get 10% of discount and maximum offers while you make the subscription. We have one more kind of subscription which we call it as iconic subscription. In iconic, we will get all the features of Plus plus some extra features such as personal mentor. Okay, a person will be assigned to you. He'll be there to plan all your academic activities 24/7. Because nowadays you will be spending a lot of time on planning, right? Matlab 25% of your time will be going for planning, what to study, how to study, what is your timetable should be. Now after this person is there, you will feel so confident, you will feel so calm, comfortable, and you can make your studies in a much better way, I say. Okay? Then live doubt solving classes, weekly reports, everything is going to help you better your performances in all the exams. 12 months if you go, 2,333. And again, do you need to pay that much? No, bilkul na. Because we have our code AMB10. Use it, get 10% of discount, maximum offers while we make the subscription. Okay. Now, if you make the subscription right now, extra 3 months will be given. So don't miss this opportunity, because this is only valid for the first 500 subscribers who make the subscription. Along with that 10% discount भी ले ले मेरा कोड यूज करके AMB10. वाई मेरा हमारा फिजिक्स वाला मतलब एंटायर फिजिक्स फैमिली का कोड. ठीक है, ये तो हो गया है. ठीक है, अरे वक्त आ गया मेरा बच्चा लोग. The 1 hour count starts now and it's time for the revision. Tell me how many of you are totally ready for the revision to get started. अभी बोल दे. With super duper energy. I have one student right now. Bhumi says she is with full of energy. ठीक है? Doubt tha Evelyn? We will be clearing it out. Why didn't you put in our chota wala group hai na Telegram ka? Good evening. Ready Srishti? Jia with full of fire wala energy. Always ready Evelyn. ठीक है. Let's start with the classes. So in this particular chapter of wave optics, we will be considering the light as a wave, right? And we are going to explain all the phenomena of light on the basis that light is a wave, or matlab light energy is being carried from one point to another in the form of a wave. Okay? And which principle actually states that the light is a wave? It is the Higgins Principle. The scientist Christian Higgins gave out some postulate related to the wave nature of light. And do you know what he told? He told that if you are going to believe all these postulates given in this Higgins Principle, he told that we can explain any phenomenon that the light is undergoing, such as reflection, refraction, interference, refraction. All these phenomena can be explained if we can believe to the postulates given by Higgins Principle. Now you will be asking, sir, what are the postulates? Just tell us. Shall we start with all the postulates given under Higgins Principle one by one? Very important. I want every one of you to write it down. We will first start with the basic concept of what is called as a wavefront. Everyone. Red color अच्छा नहीं है, black के लिए. अरे भाई बाहर आ जा. ठीक है. Everybody write the first topic, that is wavefront. We already have learned ये wavefront क्या होता है. अरे the locus of all points which are at the same phase is simply called as wavefront. Sir, just give us an example. Okay, this is a bit complicated definition. देख ले. This is a source of light. मतलब a bulb, let's say. From this ऐसे light waves जाएगा. ठीक है. Another light wave is going. Another light wave is going. Another light wave is going. देख ले. All these points are the crust points, right? Now, if we collect all these points, are we not getting a shape like this, right? This collection of all the points which are at the same phase, which are at the same angle of motion, we call it as wavefront. Okay. Now, before I write the definition of wavefront, tell me, if I am having point wala source, let's say I take a bulb, and what will be the shape of a wavefront? Is it going to be a circle like this? No, because this is just a two-dimensional figure. In the three dimension, that circle will become what? If we collect all the points around a point, which are at the same distance and which are having the same phase, it is going to be spherical in nature. Okay, so I will write shape of wavefront, WF, is spherical in nature for a point source. This is very important. You can put it in this box and learn it. Okay. Now I think you also need the definition, है ना? Wavefront का definition क्या होता है? I'll write it down. It is the locus of all points, ठीक है, which are at same phase. ठीक है. Now don't get scared with the word of locus. Locus matlab the collection of all points. I think you have learned in your mathematics. So I'm not going in deep with what is locus. ठीक है. One more thing. Usually for a point source, it is spherical wavefronts, right? Now tell me, if we take any wavefront which is very far away from the source, I'll explain you. देख ले. I have a source of light here. Usually it is the spherical wavefronts, ऐसे. But let's say as a spherical wavefront moves very far away, you can see that this sphere, this curvature of the sphere will be very less, and this will almost be looking like a straight line, isn't it? Isn't it? It will be almost looking like a straight plane like this. So wavefronts, when it is very far away from the point source, what will be its shape, or what is the shape we are going to consider? We will be considering that it will be having a plane shape. So we can have planar wavefront, when the wavefront is very far away from the source. This also you can consider. This is very important. Closer, okay, when it is very closer, we can say spherical. When it is far away, it will be planar wavefront. Note it down. Very important है मेरे बच्चे लोग. ठीक है? बहुत important है. Okay. Now, one more thing is being told here, which you all have to note it down. देखिए, ये source of light है. From the source of light, a ray of light will be emerging like this, isn't it? Ray of light. Now tell me, if you make this as a complete sphere, the direction of ray of light will be in the direction of radius of the sphere, isn't it? The radius of the sphere and the ray of light will be having the same direction. Yes. Now if we consider this as the surface of the sphere and this as the radius, there exists a simple relationship. Surface of the sphere and radius, they are perpendicular to each other, right? So to a spherical wavefront or to any wavefront in general, a ray of light will be perpendicular to it. It is very important. Can I write it down? What is it? A ray of light perpendicular to wavefront. Make it as another point. Ray of light, array baapre. Ray of light, ठीक है, perpendicular to wavefront. Now look into all these points. If you have any doubts, just let me know. Else we will move to the next one. Jaldi. And I hope you all have completed learning this chapter once. ठीक है? I'm not taking the entire chapter as such. We are doing a revision. ठीक है? Clear है ना? Jia, Bhumi, Tanmay, Shreya, Miara, everyone. जल्दी बता. Clear है ना अभी तक? Note भी कर ले ये, because I'm moving to the next page. Okay, it's fine. You are just late for 4 to 10 minutes, right? Mithilesh clear, Evelyn clear, Ayushi, ठीक है. Now make this opportunity है ना बच्चा लोग to make short notes, because I'll be only discussing the important points from the chapter. ठीक है? Sudeep, ठीक है, बढ़िया, सब बढ़िया. Now let's move to the next concept of the Higgins principle. What is said in the next part of Higgins principle? देख ले, we have a source of light. Spherical wavefronts are emerging from it. Do you know what he said? Okay, what the Christian Huygens said, that every point on the source, every point on this particular wavefront, hai na, it will be acting as another source. This will be acting as another source. We call it as secondary source. Okay, and if it is a source, obviously won't the light waves be emerging out from it? Yes, the light waves will be emerging out from it. And do you know what do we call the waves emerging from the secondary source? It is called as, dekh le, we call it as secondary wavelets. Naam kya hai? Secondary wavelets. Two things, once again, all points on the wavefront act as another source, secondary source. ठीक है? And the waves emerging from that, secondary wavelets. Fine? All good? ठीक है. Now, next one. This is our source. This is one of the wavefront. He also says how we can find out the next wavefront after a time of t. What is it? Right? Huygens principle also gives us an idea to find out the next wavefront after a time of t. Dekh le, this is the shape of a wavefront at time equal to 0. We want to find out the wavefront after a time of t. The only information that has to be known is the velocity with which the light waves are moving. Let's say the velocity is v. So in a time of t, how much distance this wavefronts will be moving? Same as the distance traveled by the waves. Kitna hota hai? If we know the velocity in a time of t, hai na, the distance traveled will be equal to velocity into t. Right? Matlab, from all the points on this wavefront, all points source of light hai. ठीक है? Waves will be emerging. How much distance it will be traveling? Throughout the direction, it will be traveling a distance of vt. Now to mark all the points, hai na, we can draw arcs of radius vt. We can draw an arc ऐसे, ठीक है? ऐसे. So we can have so many such arcs like this. And do you know what he told? If you want to find out the next wavefront after a time of t, after drawing all these arcs, hai na, just draw a common tangent ऐसे. And this will be the new wavefront after Okay, so these are the important postulates from Higgins principle. आ गया तो आ गया, सबको समझ में आ गया, है ना? अरे इतना तो बड़ा कुछ कॉन्सेप्ट कुछ भी नहीं है ना? We just have to by heart this essay. Okay, there is no logic behind this. He told that if we can believe all these postulates, मतलब we have to believe this. There is no logic behind this. Okay, वो भी ऐसे बोल रहा है, ठीक है? वो बोल रहा है कि if we can believe all these things, we can define all the phenomenons. ठीक है ना एवलीन, कुलसुम, सुमित, प्रीति? ठीक है, जिया, उत्कर्ष, everyone is like हाँ सर बिल्कुल क्लियर है. Awesome, with thumbs up. बढ़िया. Okay. अब बाकी क्या है? Now there is a small concept called as derivation, right? Or the definition of reflection and a refraction, or let's say proof of reflection and a refraction using Higgins principle. Do we need that proof? मतलब definition चाहिए क्या in this class, in this revision class? बता दीजिए आप लोग. If you want, I can do that. Or else we can move to the part of interference. Okay, just tell me. अरे COVID positive, अरे don't worry Tanmay, everything is going to be all right. ठीक है? Stay strong. Okay, everything is going to be all right. No sir, G. ठीक, I can have a mix of okay, so just diagram is fine. Okay, so I'll just draw the diagram, right? Okay, I'm not gonna go for the proof. Okay, anyway, it's a revision class, so I'll just draw the diagram, how the diagram is, because many of you are having the problem with the diagram, right? How to draw the reflection diagram using the wavefronts. Shall we do that? It is going to be awesome. देख ले. Reflection, first we will do reflection. ठीक है? Reflection using Higgins principle. Okay, we'll draw the diagram because you all can see the diagram in your textbook. Let's see how it is being drawn. For that, just consider a reflecting surface. ये a reflecting surface मतलब a plane mirror, let's say. ठीक है? To this plane mirror है ना, we are having a wavefront coming. मतलब a wavefront is coming to this reflecting surface. Do you know what we call this wavefront as? If a ray of light is coming, we call it as incident ray. So if a wavefront is coming, we call it as, नाम क्या है? Incident wavefront, WF wavefront. ठीक है? Fine. Now, if this is the incident wavefront, the question is, what is the reflected wavefront? How can we draw that? Now we are not so much comfortable with wavefront, right? So we have to introduce a concept of ray of light. Then we will convert it into final reflected wavefront. Now, for doing this problem, I'm considering two incident ray of light. One ray of light at this point. Okay, another incident ray of light at this particular point. Matlab at the extreme edges, I have considered two incident ray of light. Why I have drawn perpendicular? Q. We already have discussed in the Higgins principle. याद है? A ray of light should be perpendicular to the wavefront. How many of you do remember? सबको याद है ना? The ray of light should be perpendicular to the wavefront. S. Okay. Tell me what will happen to this ray of light. Just tell me. This ray of light will get reflected. What happened to this ray of light? This ray of light from this point will be traveling until it reaches this reflecting surface. First we will consider its motion. ठीक है? देख ले, this ray of light from this point, it will travel towards the reflecting surface and it reaches the reflecting surface from here. Let's say for this ray of light, it takes a time of t. If the light is having a velocity of v, how much will be this distance BC? Can you tell me? It takes a time of t. Okay, the lights are having a velocity of v. How much will be the distance it travels? अरे distance का formula velocity into time. So ठीक है, we will write it as v. So the ray of light at this point B is taking a time of t and travels this much of distance. ठीक है. Now देख ले इधर भी एक ray of light है, ठीक है. How much time it gets now? It also get the same amount of time. It is also having the same velocity v. So this ray of light will be undergoing reflection and will be traveling a distance of vt. Array, we don't know which direction it is. We only know the distance it is going to travel is vt. After reflection, we know that it can be like this. It can travel a vt. It will be like this, or it can be like this. We don't know in which direction it is going to travel. Actually, here we have to prove the reflection, right? So we don't know in which direction it is. So the endpoints can be any of this which is at a distance of vt. Do you know what I'm going to do? Okay, to find out all the points which are at a distance of vt from this, I'm just going to draw an arc like this. Why arc? Because any point if you take from this arc, it will be at a distance of vt. Any point on this arc can be the final point after reflection. We don't know which it is. Okay? Now, one ray of light is here at the point C. Another ray of light is on this arc, which we don't know. How can we find out what is the point on this arc after reflection? Kaise? We can introduce the concept of the wavefront again. Because wavefront, this was the incident wavefront, right? Incident wavefront passes through both the incident ray of light. So the wavefront after reflection, what do we call it? The reflected wavefront, won't it be passing through both the ray of light? One ray of light is at the point C, another ray of light is somewhere on this arc which we don't know. So won't it be passing through? Yes. So let's draw a line passing through these points. Okay? So I'm going to draw the reflected wavefront passing through the point C, and this line, let it be a tangent to this arc. Tell me why I have drawn a tangent. I know that the picture is not so exact. Why I have drawn a tangent? Because if you consider this as the final point after reflection, and if you make it as a line, that simple condition will be satisfied. What? The ray of light being perpendicular to the wavefront. So there is only one point on this arc where the wavefront and ray of light is perpendicular. So this is our final point after reflection. So this is our reflected ray of light. So that's how the figure is drawn for reflection using Higgins principle. Now I hope you know the theorem, matlab how it is done. How the angle of I is proved as angle of R, which is the basic law of reflection. Sabko pata hai ye, right? Isn't it known to everyone? Let's call Mithilesh, Myara, Swarna, Jia. Is it clear? Is it clear? Amar Singh, okay, we will try our level base, hai na? Bacha log, obviously I am going with the basic, right? I am trying to explain this concept of wave optics, hai na, from the basics. So I am trying to make everyone understand, but obviously it's a, it is a revision class. So I cannot go that basics. Okay? But I'll try to go that much of basics where everyone can understand. So Swarna, Sudeep, Bhumi, Anisha, Shreya, Captain, Srishti, Sweda, Karanveer, Bhumish, सबको समझ में आ गया. ठीक है? ठीक है? Now shall we also explain refraction using Higgins principle? Okay, समझ में आ गया मेरा? ठीक है, ठीक है, ठीक है, ठीक है. Okay, now we are not going to do any questions here in this class. Okay, it is just the concept revision. Okay, now refraction. How a refracted ray of light is being found out using Higgins principle. Next page pe dekh le, what are we going to do? We are going to prove refraction using Higgins principle. Now, I know that from this chapter, these diagrams are difficult for many. So, many of you have personally asked me also, इसीलिए मैं कर रहा है. ठीक है? Okay. देख ले how to do this. Now, I am taking a line of separation. This is the first medium where the light is having a velocity of v1. This is the second medium where the light is having a velocity of v2. Let's consider that light is moving from a rarer medium to a denser medium. So if it is denser, obviously the V2 value, the velocity of light at the denser medium will be lesser than V1. पता है ना? अरे denser पे light will be moving slowly. Okay. Now let's start explaining. Same initial part तो same here. मतलब I'll be considering an incident plane wavefront ऐसे. So this is our incident wavefront. Okay. Now I'm gonna consider two incident ray of light at the extreme ends. One ray of light either. देख ले. One ray of light I'm gonna consider here. Okay. Another ray of light I'm gonna consider here. So these are the positions of ray of light at t equal to 0. At t equal to 0, these are the positions of the ray of light. देख ले, what will happen to this ray of light? इधर का, अरे it will be traveling straight ऐसे in the same medium, right? ठीक है. This ray of light will be traveling ऐसे, 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 and it will be meeting this line of separation between the medium. This is B, let's say. This is point C, let's say. This is point A, let's say. Now, how much will be BC? BC will be equal to, let's say it takes a time of t. ठीक है, BC will be equal to the velocity with which it moves. कितना velocity है? V1 है. So distance will be equal to velocity into time. हो गया? This ray of light here, right? If it gets a time of t, will be traveling a distance of V1t and will be reaching the point C. ठीक है? So the ray of light reaches here after a time of t. Array, what will happen to this ray of light? Array, this ray of light was at this point at t equal to 0. What will happen? Just tell me, क्या हो जाएगा इसको? देखकर बता. Array, this ray of light, okay, will be moving to the second medium. Okay, and how much distance it is going to move? It is also going to get same time t, है ना? Same time t. In what distance it will go? Array, this ray of light is now moving in the second medium. Second medium पे velocity v2 है. ठीक है. So how much distance it is going to travel in a time of t? That is equal to v2t. Distance it travels will be equal to velocity into time. In the second medium velocity v2 है. So v2 into t आ जाएगा distance. Now, does anyone know what is the direction it is going to move? अरे हमको पता नहीं. So it can either travel v2t in this direction. It can either travel v2t in this direction. It can either travel v2t in this direction. अरे हमको पता नहीं. We just know that the end point is going to be at a distance of v2t. So by keeping one point here, we are going to draw an arc, okay, with a radius of v2tq, because any point on this arc which is at a distance of v2t can be the final point after refraction, but we have to confirm. कैसे? Same by drawing the incident wavefront है हमारे पास, we have to draw the refracted wavefront. How can we draw the wavefront? Two conditions has to be satisfied. It should pass through ray of light. One thing. ठीक है? Second thing, it should be perpendicular to the ray of light. So these are the points of ray of light after time t. So wavefront, I can start drawing from here. देख ले, देख ले, देख ले, and I'm gonna draw tangent to this particular arc. Why tangent? Because at this point, wherever this refracted wavefront is making tangent, देख ले, this particular ray of light is making an angle of 90 degree with the refracted wavefront, because the ray of light has to make 90 degree with the wavefront, then only their conditions will be satisfied, right? So we can get to know that it is at this particular point the final refracted ray of light is reaching. So this is our refracted ray of light, and this is angle of refraction, and this is angle of incidence. अब समझ में आ गया? आ गया? कॉन्सेप्ट सबको समझ में आ गया अच्छे से? रिफ्रैक्शन यूजिंग हाइगन्स प्रिंसिपल. श्रेया V2 greater than V1, अरे बाप रे, डेंसर का वेलोसिटी कैसे, अरे दैट इज N2 greater than N1 होता है, V2 नहीं ज्यादा होता है. अरे you just think, okay, we have air and water. एयर तो रेयर मीडियम है, वाटर तो डेंसर मीडियम है. V1 velocity in air, V2 velocity in water. Where can we have larger velocity of light? Is it in air or is it in water? Array, it is obviously in air, because when it passes through water, it's a dense medium with so much of molecules. So water will undergo so much of resistance when it passes through it. So उसका velocity कम ही हो जाएगा. जोजो, श्रेया, भूमि, म्यारा, डिम्पल, जतिन, कैप्टन, सुदीप, अरे सबको समझ में आ गया, राइट? हाँ, रेयर मीडियम पे वेलोसिटी ज्यादा हो गया. ओके, वेरी गुड वेरी गुड. अरे जतिन, आपका नाम तो ले लिया, सबका नाम ले लूंगा, है ना? मैं तो अच्छा वाला भैया. नाउ ऑन द टॉप ऑफ द चैट स्क्रीन, कैन यू ऑल सी अ लिंक, छोटू सा, ठीक है? दैट इज द लिंक फॉर माय Unacademy प्रोफाइल. मतलब if you just follow my profile in Unacademy, you can get notification of all the free classes I take. Okay, it doesn't have to be all the paid classes. You can join all my free classes also. So you can click on that above wala link. ठीक है, you can follow me on मतलब not Instagram, ठीक है, Unacademy वाला profile, and you can get notifications whenever I take free classes there. ठीक है? ओके, तो हम जा रहे हैं बच्चा लोग, हम जा रहे हैं. वी हैव टू प्रोसीड फर्दर. नाउ कोहेरेंट सोर्सेस एंड इनकोहेरेंट सोर्सेस. अरे इट्स टाइम फॉर इंटरफेरेंस. अरे 37 मिनट्स हो गया, ठीक है, बहुत ज़्यादा है कंप्लीट करने के लिए, लेकिन भैया तो बिल्कुल तेजी से नहीं चलेगा. आई विल मेक एवरीवन अंडरस्टैंड. कोहेरेंट सोर्सेस एंड इनकोहेरेंट सोर्सेस क्या होता है, देख ले. वी हैव अ सोर्स ऑफ लाइट. सोर्स ऑफ लाइट मतलब क्या? Don't think the source of light is something just like an alien spaceship. Okay, you shouldn't be having such a mystery. What do you mean by source of light? अरे ऊपर देख ले, बेल्ट दिख रहा है ना आप लोगों को, वो ही है सोर्स ऑफ लाइट. Another source of light, waves आ जाएगा इस पे, waves आ जाएगा इस पे, ठीक है. Let's say this is having a wavelength of lambda 1, this is lambda 2. Frequency is f1, frequency is f2. Initial phase of this is phi 1. Let's say this is having a phase of phi 2. You all know what are phases, right? The angle that is corresponding to each and every point. This point is having 0 angle, so phase 0 है. At this point angle कितना है? 90 है, so phase 90 है. So not a big task. You all know sine curve better than me, ठीक है. When can we call S1 and S2 as coherent source? When can we call S1 and S2 as coherent? बोल दे. These two sources will be coherent sources when their wavelengths are equal, when their frequencies are equal, ठीक है. Now phi 1 and phi 2 are their initial phases. So phi 1 minus phi 2 क्या होता है? Phi 1 minus phi 2 क्या होता है? Phase difference होता है. Difference in phase between both the phase. Now, if this is remaining as a constant throughout, okay, if this phase difference is remaining as a constant throughout, then we can say that these two sources are coherent sources. I think many of you are having doubt with the phi 1 minus phi 2 constant. Sir, can you please explain? देख ले. You know that both of them starts with a phase of 0. देख ले, इधर का phase 0 है, इधर का भी phase 0 है. मतलब here in this case phase difference कितना है? phi 1 minus phi 2 कितना है? 0 है. Now if it wants to be coherent after equal intervals of time, still the phase difference should be 0. मतलब देख ले, this light waves है ना, after a time of t reached here after some time, this also have reached here. What are their phases? When it reaches here, this phase is 90. इधर का phase कितना है? 90. Phase difference कितना है? 90 minus 90, 0, which is same as initial. Then we can call this as a what? A coherent source. Very important, because so many questions will be popping up from this part, right? To understand whether the given sources are coherent or not. ठीक है ना? अरे खुश हो जा, हैप्पी हो जा, ठीक है? समझ में आ रहा है तो थोड़ा खुश हो जा, रिलैक्स हो जा, राइट डाउन कर ले जल्दी से। हो गया तो बता। ओके, नाउ ये हो गया तो कोहेरेंट। अरे इफ वन ऑफ दिस कंडीशन इज नॉट satisfied, let's say phi1 not equal to, अरे lambda1 not equal to lambda2, f1 not equal to f2, any of this condition is not satisfied, then we will call it as incoherent. I can write it down. Incoherent. When will it be incoherent? When any of the above conditions are not satisfied, ठीक है, then incoherent होता है. Okay, when any of the above condition मतलब conditions for coherent sources, if any of them is not satisfied, then that sources of light will be incoherent. ठीक है, आ गया समझ? अच्छी से, मुच्ची से, सच्ची से, मुच्ची में, isn't it? मेरी, okay. जिया, म्यारा, जोजो, करण, कैप्टन, ठीक है. Now, आ गया बच्चा लोग, आ गया वक्त, आ गया to learn that super important topic. Jia, Bhumi, Dimple, everyone listen to me here. It's very important to start learning about interference. Arre baap re. Sir, this is always a scary dream for us. It's so hard to understand. देख ले, even in this revision class, I am totally confident that I can make you understand within some time what is this interference. देख ले, interference क्या होता है? In simple words, I have a tight string, okay, held by two hands. One hand is making a wave like this to pass it towards right direction. It is moving towards right. The other hand, which is holding the other end of this tight rope, is making a jerk here and making a wave ऐसे to make it move towards the left direction. देख ले, this will be coming ऐसे ऐसे ऐसे. At a particular point, won't they be meeting each other, right? And at the point, whatever they are meeting, won't these two light waves be interacting each other, right? This interaction of the two or more than two light waves at a single point, we call it as interference. What is it? I'll just write it down. Interaction of two or more light waves. वो क्या होता है मेरा बच्चा लोग? वो होता है interference. ठीक है. Now, sir, just tell me how to find out the displacement, because this particular point on the rope has displaced to a value of y1. This particular point on the rope, let's say it has displaced to a value of y2. At this point where two waves of light are meeting, sir, what is the total displacement? That is explained in superposition principle. So superposition principle talks about what? Yes, the net displacement a particle can have when interference happens, or when two or more light waves interfere. What is the net displacement? That is explained in superposition principle. We all know, if the first wave is making a displacement of y1, and if the second is making a displacement of y2, net displacement y is equal to y1 vector plus y2. है ना, जस्ट ऐड कर ले वो, ठीक है, डिस्प्लेसमेंट ऑफ द फर्स्ट प्लस डिस्प्लेसमेंट ऑफ द सेकंड ऐड कर ले, यू विल गेट द नेट डिस्प्लेसमेंट. सिंपल. आई होप सबको समझ में आ गया अच्छे से, राइट? अच्छे से, नन्ना से, मुन्ने से, isn't it? In such a cute way, isn't it clear? Interference क्या होता है? Superposition principle क्या होता है? Fine? Okay. Now I'm not going to look for the chat right now. We will continue, right? We'll talk about the constructive interference and destructive interference. Abhi. Dekh. Everyone listen to me here. when can we have constructive interference? Very important. है ना? These are the basic topics. Constructive interference. ठीक है सर, बता दीजिए. Now, when can we have constructive interference? देख ले, at a point we are having one light wave with an amplitude of A1. Okay. Another wave is at the same point, where at the same point है ना, the crest of both the waves are at the same point at the same time. मतलब they are overlapping each other in such a manner that the crest is coming at the same point. In this condition, what will happen? देख ले, this wave will try to displace it upward. This is also trying to displace it upward. मतलब the net displacement will get added up and the total amplitude will be equal to how much? A1 plus A2. So if interference happens in such a way that the total amplitude gets added up, we call it as constructive interference. Very, very, very important. Okay. Now, other things that can be asked here is, sir, when can we have constructive interference? We have learned कब हो जाएगा constructive interference? Whenever the phase difference, first we'll talk about phase difference, 0 होता है. Right? When it is 2 pi, when it is 4 pi, matlab when it is even multiples of pi, we can have constructive interference. In general way, you can write if it is 2n pi, we can have constructive interference. What is the path difference to be for constructive interference to happen? हमको भी पता है lambda होता है 2 lambda, 3 lambda, matlab it should be an integral multiple of lambda. The path difference should be to have constructive interference, isn't it? Right. One more thing is left to be learned from here, that intensity कितना होता है? Intensity matlab the energy per unit area per unit time, or intensity in simple way is let's say the brightness of the light, right? What will happen to the brightness of the light, okay, after constructive interference? The first one is having an intensity of I1, second one is having an intensity of I2. कितना हो जाएगा? Before giving you this, I'll give you a small relationship between amplitude and intensity, that I is equal to K times square of amplitude. This is very important. Or intensity is proportional to square of amplitude. Once again, intensity is square of amplitude. Now here we can substitute for A1 and A2 in terms of I. So let us take the square root on both the sides. Root of I is equal to root of K into A. So A कितना होता है? Amplitude is equal to root of I divided by root of K. From here, substitute कर ले. A will be equal to root of I by root of K. A1 will be equal to root of I1 divided by root of K. Plus A2 will be equal to root of I2 divided by root of K. Root K common है, cancel कर ले. Root I will be root I1 plus root I2. Squaring on both the sides, we will get I is equal to root I1 plus root I2 the whole square. I squared on the left hand side, right hand side I will be equal to root of I1 plus root of I2. Simple as that. Right? देख ले कितना आसानी से हम कंस्ट्रक्टिव इंटरफेरेंस को कर दिया, isn't it? कितने आसानी से बहुत आसानी से कर दिया है ना. म्यारा, प्रीति, everyone just yell out and tell हाँ सर till constructive interference super great. सब समझ में आ गया. Right? Clear? Evelyn, मिथिलेश, अमीशा, डिम्पल, भूमि, सबको अच्छे से. Awesome way, in such a beautiful, super great way. Getting it? Karanvi, Srishti, ठीक है. Everyone is just giving me thumbs ups here. ठीक है, बढ़िया बात है. Okay, कुछ भी doubts नहीं है. I think that's what everyone says, right? Shreya, Bhumi. Okay. So someone is spamming using Miara's account. ऐसे कैसे हो सकता है? अरे whoever is doing that, please don't do it, है ना? Because everyone is here to learn something, right? Exams are coming. क्या मिल जाएगा आप लोगों को डिस्टर्ब करके दूसरे को, right? Now, whoever doesn't want to see those messages, I think nobody wants to see that messages. Just click on that person in your chat box, option will come block. Click on the block option. So that person will be removed from your personal chat. Okay, fine, बढ़िया, right? Miyara, Bina and everyone. Okay. So हमारा constructive interference का हो गया. You all, I hope, noted this down. Now we will go for destructive interference. ठीक है? जाओ बाय. ठीक. Destructive interference, everyone. Destructive interference. ठीक है. When can we have destructive interference? देख ले. When we have one of the wave reaching at a point with its crest initially, and the second wave reaching at the same point with trough initially, देख ले, A1 and A2. The waves are trying to displace the points in the opposite direction. ऊपर वाला wave is trying to displace it upward and this is trying to displace it downward. So what will happen? Net amplitude क्या हो जाएगा? अरे cancel हो जाएगा, मतलब net amplitude A will be A1 minus A2. Why A1 minus A2? Opposite direction पे. ठीक है? Now how can we write the formula for intensity in a similar way? That is equal to I will be equal to root I1 minus root I2 the whole square. Same concept. देख ले. Here it was root I1 plus root I2 the whole square. ठीक है? So in destructive minus आ जाएगा in corresponding to this negative side. बस. Tell me at what all phase differences we can have destructive interference. Delta phi will be equal to, yes, pi, 3 pi, 5 pi. मतलब for odd multiples of pi, मतलब for all 2n plus 1 pi values we can get destructive interference. What about the path difference? Delta x will be equal to lambda by 2, 3 lambda by 2, 5 lambda by 2. ऐसे मतलब if it is an n plus half lambda, in that case we can have destructive interference. Okay? Yes? Done. Now, copy kiya I suppose, right? If you have understood constructive, understanding destructive is not a big deal, right? I think you all agree with me on that. Okay? Fine. So constructive bhi aa gaya, destructive bhi aa gaya. Now sun le, right? The two waves are interfering with some random phase difference value, not in these multiples of pi, 3 pi, 5 pi, or not in multiples of 0, 2 pi, 4 pi, some random, let's say 60 degree, let's say 70 degree, 75 degree. What will be the net intensity? Okay? What will be the net value of amplitude? Let's find out. We'll just write down the formula, which will be important for all your competitive examination. Net amplitude will be equal to, in that case, A1 plus A2 plus 2 A1 A2 cos phi. What is this formula for? To find out the net amplitude, if two waves, okay, with amplitude A1 and A2 interfere with a phase difference of phi, this is a formula to find out net amplitude. Okay. Similarly, what will be the formula to find out intensity? I will be equal to this will be, here will be equal to root of A1 plus A2 plus 2A1 A2 the whole square. ठीक है? Root of A1 square, अरे बाप रे, square था. Okay? थोड़ा गलती हो गया. A is equal to root of A1 square plus A2 square plus 2A1 A2 cos phi. अरे similar. देख ले, 2 वेक्टर है आपके पास. Vector A है, vector B है. By an angle of theta. So what will be the resultant? Root of A square plus B square plus 2AB cos theta, right? Similarly, two amplitudes, phase difference phi, net value of amplitude ऐसे. Formula for intensity, I'm not going for the derivation, we'll write it as such. That will be equal to I equal to I1 plus I2 plus 2 root of I1 I2 cos phi. ठीक है? ये फॉर्मूला है एम्पलीट्यूड का, ठीक है? ये फॉर्मूला है इंटेंसिटी का. I think you do all remember. ठीक है, रिविजन क्लास है. आई एम जस्ट ट्राइंग टू मेक यू रिमेंबर ऑल दीज थिंग्स. राइट एवलीन, श्रेया, सबको समझ में आ गया? यस यस यस, ऑल गुड, फाइन. Yes, remembered. Very good. Now, what all are the important topics that is left to be discussed? Interference and diffraction. Shall we complete? Everyone, right? Okay, here we go. Everyone, Bhumi, Mithilesh, Shweta, Myara, Arora, everyone. Dekh le. Now we will talk about the Young's double slit experiment. Still, so many of you don't know. अरे कॉन्सेप्ट सब पता है, इफ न्यूमेरिकल क्वेश्चंस आस्क वो भी पता है, हाउ टू आंसर, नो ऑल द फॉर्मूलाज, बट सो मेनी आर देयर हु डजंट नो ये व्हाट इज दिस यंग्स डबल स्लिट एक्सपेरिमेंट, व्हाट डज इट टॉक्स अबाउट. इट्स वेरी सिंपल. यंग्स डबल स्लिट एक्सपेरिमेंट is an experimental proof. What? It's an experimental proof that light can undergo interference. This was the first method. है ना? Before this, Christian Huygens, the scientist, has given so much of principle, but to back up that there was no, let's say, experimental proof. कोई proof नहीं था, right? He just gave some concepts and he started explaining. So Young's double slit experiment is the first experimental proof, the first real proof which said that the light can undergo interference. If light can undergo interference, interference can be only undergone by waves, है ना? Which says light is actually a waveform. आ गया समझ? ठीक है, this is what we are doing in Young's double slit experiment. देख ले, a quick overview of Young's double slit experiment. देख ले, here we'll be having a source of light. ठीक है, in front of that you'll be keeping a double slit. Okay, slit S1 let's call it, and S2 let's call it. And in front of that we'll be having a screen. Tell me what all we have learned here. Exactly at the center क्या मिल जाएगा हमको? We will have the central bright band. Why bright point or why a high brightness point? Because at this point the light waves coming from the source 1, the light waves coming from the source 2 will be undergoing constructive interference and will be producing a high intensity point here. So here what is produced? Constructive. Just wrote it there. Now on either side of central bright we'll be having the first dark point. First dark, first dark. And after that we'll be having the first bright point. Okay, then this continues. Now this alternate bright and dark fringes, we simply call it as interference pattern. Now wherever we have dark, we know that it is destructive interference that is happening. Wherever we have bright, what is happening? The constructive interference is happening to produce a bright point. ठीक है, there are some I'm sorry मेरे बच्चा लोग, there are some formulas that we have derived. याद है? Some formulas that we have derived in our classes to find out the distance to the dark points. देख ले, this is the nth dark point. There is a formula to find out the distance to this nth dark point, y and d. Formula क्या था? Tell me. Distance to the nth dark band is given by n minus half lambda capital D by D. I'll explain what each and every terms are. Distance between slit and screen क्या होता है? Capital D. Distance between two slits छोटा d. ठीक है, lambda क्या होता है? Wavelength होता है. N corresponds to, or N talks about which dark fringe we are talking about. If in fifth dark we are talking, N will take the value of 5. Substitute कर ले, we'll get the distance to the dark bands. Similarly, if we have the nth bright band here, देख ले, either we have the nth bright band. If we want to calculate the distance to the nth bright band, we have a formula. क्या था? Same. Instead of n minus half, put n there, lambda capital D. Bas, right? It's not a big deal. And we have learned one more thing. क्या था? अरे this dark band है ना, देख ले, the dark band starts from here till the bright band start, it will be the dark band. मतलब this much will be the width of dark band. Similarly, the bright band starts here till it reaches the next dark band, it will be the bright band. So each and every band, whether it is a dark band, whether it is a bright band, has its own width, right? And that width we call it as fringe width. Fringe width, the width of the dark bands or the bright bands, beta. Okay, formula kya hai? How can we calculate? That is given by lambda capital D by small. All are having the same width in the case of this interference. ठीक है? So, did all these things help you to remember all these concepts that we have learned? Tell me, Jia, Myara, Mithilesh, Bhumi, Karanveer, याद आ गया? Clear? Okay, सब आ गया ना? All those things that we have learned. Evelyn, it's a 1 hour revision class hai na? So there is, I can't go beyond this, right? Else the class will extend just like that, because explaining the entire concepts of diffraction will take at least half an hour, which is not possible during this. If I take a one shot complete chapter revision, I'll try to do that. ठीक है? Fine. Arey, very good, Karanveer. Yes, wherever we have dark point, they are undergoing destructive interference there. समझ में आ गया? It's not a big deal. ठीक है? Now we'll talk about diffraction. ठीक है? Diffraction क्या होता क्या है? Maybe in this case, है ना? Everybody will be knowing, हाँ, the single slit diffraction pattern, but nobody knows the phenomenon of diffraction. Reflection, when we talk about, we know that it is a bouncing back of light. Diffraction, sorry, not diffraction, refraction, when we talk about, it is the bending of the light when it moves from one point to another. Diffraction क्या होता है, sir? Still we don't have an idea. So many in the class, right? देख ले. And some also have asked me, sir, please explain करा दे ये diffraction क्या होता है. I'll just give you an idea. देख ले. We have this screen here, right? Okay. In front of the screen, I am keeping some obstacle, matlab which will not allow the light ray to pass through it. So I am making this much of light ray to pass as such. Tell me what you can see on this, matlab, what do you expect to see on the screen? What we can expect to see on the screen is, as this obstacle block this much of light rays, we usually expect this much of region till here, it will be bright. This is what we expect, okay? And the remaining region will be shadow, matlab dark region. This is what we expect, ठीक है? But light has a chotu wala property which we called as diffraction. वो क्या होता है? At this particular point है ना, at this particular point or the corner of this particular obstacle, light will be bending towards the shadow region, which makes this much more region bright. ठीक है? Light is just bending at the point of obstacle S. Can you see that? And this bending of light at the corners of objects, we call it as diffraction. समझ में आ गया? I'll just write down the definition in a very simple way. Bending of light towards shadow region or the dark region, shadow region. ठीक है? In simple words, we can call diffraction as that. ठीक है? वो bend कर रहा है and this bending toward the shadow region को हम बुलाता है diffraction. अब थोड़ा आइडिया मिल गया ये डिफ्रैक्शन क्या होता है हमारे बच्चा लोग? थोड़ा आइडिया मिल गया ना? श्रेया, म्यारा, सलोनी, मिथिलेश, एवलिन, you also asked me, sir, okay, how is this? I think now you got an idea. ये डिफ्रैक्शन क्या होता है? Right? Just have a look at it. पता नहीं आज है ना बहुत thirsty लग रहा है. Okay. Now moving on. Now we'll discuss about the single slit diffraction pattern. Single slit diffraction मतलब we have a छोटू वाला slit, single slit, ठीक है, where the slit width है ना, the width of the slit is actually A. In front of the slit, I'm keeping a source of light. Okay, once we switch on the source, light waves will be coming, and if we keep a screen in front of the slit, what we can observe? What we can observe is exactly at the center, we will be having the central bright band, and the central bright band will be extended until the first dark band is formed. Matlab, till the first dark band is formed, till here central bright band, and till here it is central bright band. Then we have the dark band. After the dark band, we have the first bright and first bright on either side. Then we have the second bright, then we have the third bright, ऐसे. Now, what has to be learned from here, or what all numerical questions that we can expect? देख ले. Let's say this is the nth dark point. Now, let's say this is the angle that it makes to the nth dark, theta n dark. We have the formula to find out this particular angle that the nth dark band makes with the horizontal or the central band. Formula क्या है? Is equal to n times lambda by A. Here thoda difference है, right? Because in n lambda cases, we're actually undergoing constructive interference. मतलब bright points we got an interference, इधर उल्टा मिल जाएगा. I'm not going for the explanation because at least it will take half an hour. Revision class है, so I'm restricting myself from doing that, and this is more than enough. ठीक है? So the angular distance to the nth dark band is n lambda by A. Similarly, if you want to find out the angle to the nth bright band, formula क्या होता है? That is equal to n plus half lambda by A. ठीक है? If we want to find out the angle to the nth bright band, formula is n plus half lambda by A. Someone will be asking, sir, we don't want the angle. हमको चाहिए तो चाहिए ये distance चाहिए. मतलब हमको angle नहीं चाहिए. We want the distance from the central bright to the nth dark or to the nth bright. Shall I give you chotu wala method to find that out? अरे theta is equal to opposite by adjacent. ये capital D है, isn't it? Distance between a slit and a screen. So theta can be replaced as y by adjacent, which is capital D. That is equal to n lambda by A. So from here, you can find out y, the distance to the bright or dark accordingly. You can make the substitution here also if you want to find out value of y. ठीक है? Not a big deal. है ना? छोटू सा नन्नू सा मुन्ना सा बात है. Okay, and one last thing from the part of single slit is, right, they'll be asking you, yes, central bright band है ना, देख ले, the central bright band is extended to this much of region. Until the first dark band comes, it is the central bright that is extended on either side. ऐसे question can come, what is the angular separation of central bright band? Formula is 2 times lambda by A. The angular width from the center, if you draw angles and if you draw lines to the endpoints, the angle that it makes, this is theta CB. Okay, angle is 2 times lambda by A. One last thing, that angular fringe width कितना होता है? अरे this bright bands, dark bands है ना, has a width. Now if you express the width in terms of angle, कितना होता है? वो तो same है. So theta fringe width, angular fringe width is equal to lambda by A. मतलब you can see that the angular width of the central bright band is twice than the angular width of remaining dark bands and the bright bands. This is very important because in so many cases, they'll be asked to compare the interference pattern and what the diffraction pattern. One of the differences is this, matlab central is having twice compared to the other fringes, but whereas in the case of interference वो pattern का width है ना same लगता है for the central bright, for the other bands है ना पूरा का पूरा will be having the same width actually. Clear? That is very important part. Okay, and is there anything more left? Okay, one more difference. एक और difference है that I need to tell you that देख ले in the case of diffraction, as we move away from the center, देख ले if we take the first bright, then if we take the second bright, third bright, the intensity or the brightness or the contrast, let's say, right, of the bright bands keeps on decreasing as you move away from the central bright band. That is also, we can say it as a difference, right, from the interference pattern and the diffraction pattern. All these are important. Fine. Fine है ना मेरे बच्चे लोग? इंटरफेरेंस तो हो गया हमारा, डिफ्रैक्शन पैटर्न भी हो गया, ठीक है. एक छोटू सा नन्नू सा मुन्नू सा टॉपिक है, वो तो है हमारा पोलराइजेशन, राइट. एंड पोलराइजेशन इज ऑलमोस्ट लाइक अ डिलीटेड टॉपिक. सो बट एनीवे आई विल गिव यू अ स्मॉल आइडिया ये पोलराइजेशन क्या होता है. ओके, एवरीथिंग इज क्लियर राइट श्रेया? आ गया तो आ गया, सबको समझ में आ गया. और क्या, और क्या. एवरीवन सम आर लाइक सर थोड़ा पानी पी ले. ठीक है, थोड़ा पानी पिए. Okay, shall we proceed further? Sudeep, Amesha, Secret Girl, Karanveer Singh, just tell me, sir, we are good to go. Last part, matlab the last part of this particular chapter, polarization. Clear है ना? Note किया है ना what all important topics are being required. All these points, matlab all these concepts are so much necessary. Clear? Karan, Amish, Evelyn, Ashu, Shrishti, ठीक है. Okay, we are good to go. Arey, who is having a very bad day? Mera, what happened? Okay, maybe because that person was spamming, right? And it's fine, leave it happens, right? I can understand the remaining students know it's not you, so chill, right? Because spammers comes and go. We have only one life, so just chill. Moving on. Last topic of this particular chapter, then we will wind up our discussion, is polarization. First, we have to understand polarized light क्या होता है, unpolarized light क्या होता है, and ये polarization क्या होता है. देख ले, light is an electromagnetic wave. मतलब क्या है? Light will be having the electric wave ऐसे, देख ले, ठीक है. Along with that, it will be having the magnetic wave ऐसे. Okay, when electric waves and magnetic waves are there, okay, this is B, there is a simple relationship that is being formed that both of them will be perpendicular to each other. Matlab, if the electric field is making the displacement in the y direction, the magnetic field will be making the displacement in the z direction, and this will be moving in a direction perpendicular to both of them. Which direction is perpendicular to y direction and z direction? That is x, है ना? So ये wave है ना will be moving in the x direction. So velocity will be there in the x direction. ऐसे. Okay. In a simple way, if we draw this, the velocity is gonna be in the x direction. Let's say the electric field is gonna be in the y direction, and the magnetic field is going to be in the z direction. Matlab, if you consider this electric field and magnetic field, it is going to be in a plane dekh le, I don't know whether it looks like that. Okay, this electric field and magnetic field will be in a plane perpendicular to the direction of motion. Can you see that? Yes. Next question. Is the electric field and magnetic field, is it going to be always in this direction? No. What happens is this electric field keep on rotating in this particular plane which is perpendicular to the direction of motion. Matlab, at one time electric field will be making its displacement as a. Next time it will rotate a bit and will start making the vibration in this direction. Obviously, along with that, magnetic field will also be rotating because they have to maintain that 90-degree relationship, right? Okay. After some time, the electric field will again be rotating as a. We'll use another color. देख ले ऐसे था electric field. After some time it will rotate like this. It will rotate like this. मतलब this electric field will be vibrating by making a complete rotation throughout the plane. मतलब ये कि the electric field will be having a vibration throughout the plane. Such kind of light we call it as unpolarized light. What is it? We call it as unpolarized light. What is unpolarized light? Where the electric waves are vibrating in all the directions of a plane which is perpendicular to the direction of motion. That is called as an unpolarized light. If you want, I can write down the definition here. Okay? Unpolarized light can be defined as, it's a light where electric field rotate in a plane perpendicular to the direction of motion. है ना? If this particular thing happens, है ना मेरा बच्चा लोग, then we will say that this is an unpolarized light. ठीक है. Now what will be polarized light? What will be a plain polarized light? If the light is only making a vibration in one single direction, if the electric field vibrate in one single direction, उसका नाम होता है plain polarized light or simply polarized light. Won't there be a process? मतलब converting this unpolarized light to polarized light, वो process को हम कहते हैं polarization. आ गया समझ? आ गया समझ? I'll write it down, देख ले. First thing, what is polarized light? Polarized light. Electric field vibrate in one single direction. ठीक है? If it is vibrating only one single direction, let's say it is vibrating only in the perpendicular direction, or let's say it is only vibrating in this horizontal direction, then we call it as polarized light. And polarization क्या होता है? Polarization क्या? Very simple. It is the process of converting polarized unpolarized light to polarized. And what are sunglasses, Anna? That's what it doing is polarization. The sunlight which is coming to our eyes is unpolarized, and that is converted into as polarized light by the lenses of the sunglasses. So what lenses of our sunglasses are doing? Actually polarization कर रहा है वो. Have a look at it. ठीक है? Very important है. Okay, what is unpolarized light? Polarized light क्या होता है? Polarization क्या होता है? होता क्या है मेरा बच्चा लोग? आ गया समझ? नोट किया सबने? सुदीप, म्यारा, चेतन, एवलीन, उदित, अरे मैं तो बिल्कुल बढ़िया. यस हनी, अरे ठीक है. सो बाकी क्या है? नन्नू सा मुन्नू सा टॉपिक, मतलब what is called as Polaroids. Now for polarization to happen, we should be having some material, right? So that crystals that we use for polarization, we call it as Polaroids. Okay, we call it as Polaroids. Polaroids. Okay. Now, let's say when an unpolarized light is coming, which is having vibrations in all the direction towards this polarized, what will happen? In this Polaroid, there is an axis called as pass axis. The alignment of the molecules is actually making this pass axis to happen. Okay? Now, what this pass axis will do is only those vibration in that direction, okay, the vibration aligned in the direction of pass axis, here in this case it is in this perpendicular direction, and only that will be allowed to pass through it, remaining vibrations will be cut out. Okay? So after it passes through the Polaroid, the light will be having its vibration only in one single direction. Okay? So Polaroids does polarization to an unpolarized light. Okay? Let's say the light incoming is I0. How much will be the intensity of light after it passes through the Polaroid? It will be converted exactly. Intensity I0 it was. Now the present value of intensity will become half the initial value, I0 by 2. Okay? Fine. Last thing. After the first Polaroid, which we call it as polarizer, if we are keeping one more Polaroid here, एक और Polaroid लगाया, and let's say this was the initial direction of pass axis in the vertical direction. The pass axis of the second Polaroid is making an angle of theta. The intensity of light that is coming out I dash will be equal to what was intensity of light coming incoming though? I tha. So that will be equal to I cos square theta. Okay? And this is actually called as law. Fine. And एक नाम भी दे दिया है for the second Polaroid. उसका नाम है analyzer. Okay. Some important equations from the polarization. I hope you do remember. हम तो क्लास पे डिस्कस किया है, right? Maloo's law, polarization, Polaroid, ठीक है, सब आ रहा है ना? Is everything coming to your mind? हाँ सर, ऐसे ही था, ऐसे होता तो ऐसे ही था, right? Okay, fine. Shreya Bhumi. Okay, now last thing. हो गया हमारा बात तो हो गया. Remember Brewster's angle. Brewster's angle तो समझ में पता है क्या आप लोगों को? देख ले. We have a line of separation. Now, an incident ray of light comes. Let's say this is an unpolarized light. An unpolarized light is coming. What will happen? We know that no medium or no surface is completely reflective and completely transparent, right? So we know that some of the light rays will be reflected, some of the light rays will be refracted. Now, if the reflected light ray is found perpendicular to the refracted light ray, it is found out that in this case alone, this reflected light ray is found to be polarized. Only in which case, I hope you do remember, we have given a complete explanation. Gist of that particular thing is, if the reflected light ray is found perpendicular to the refracted light ray, the reflected light ray was found to be plane polarized. Okay, and at that time, the angle of incidence, we call it as Brewster's angle. So the angle of incidence for which the reflected light ray is plane polarized, we call it as Brewster's angle. Formula yaad hai kya? If this is having, the second material is having refractive index of 1, if the first material is air with a refractive index of 1, the formula that you have to know is tan of Brewster's angle is equal to n. हो गया. That was the last topic, the final topic of the session. आ गया समझ सबको? Yes? Is it clear? Evelyn? Wow, Evelyn, that's a confidence, right? So I think this particular session has boosted your confidence. So this was just a revision session, okay, to revise and to go through all the formulas and the important definitions from this particular chapter, which we have completed in the last week, right? ठीक है. अरे खाने खाने के लिए जा रहा हूँ मैं. बिल्कुल, आप बिल्कुल सही बोला. ठीक है. Tell me, what are we gonna do on this Monday? Monday पे हम क्या करेगा? इसी Monday को क्या करेगा? जल्दी बोल दे everyone, Amisha, Evelyn. Everyone just yell out and tell me what we are gonna do on this Monday. नया chapter शुरू करेगा on this Monday. ठीक है. Monday we are gonna start a new chapter, modern physics. मिस मत कर ले मेरा बच्चा लोग. टाइम क्या है? 8 p.m. We all know how much important chapter this is, right? You will get 25 out of 20. अरे वाह. वही है confidence, right? So I'm expecting every one of you for our class on Monday at 8 p.m. Don't miss it. Miss ही मत कर ले. ठीक है? बहुत important है. बहुत important मतलब super important है. Now, at the same time, if you want to know when is my special classes, which are the free classes that is happening on the platform, you can see a small link is given on the top of our chat box, right? वो link click कर ले, you can follow my Unacademy profile. So whenever a new class comes, है ना, whenever a new free classes come, I'm not talking about paid classes, है ना, whenever a free class come, you can get the notification. ठीक है? Fine है ना? Awesome है ना? ठीक है. Now we are moving on. Now Unacademy Prodigy program is going on मेरा बच्चा लोग. It's an amazing way where you can get scholarship not just now for your college days also, where 20 lakhs ka college grant will be given. Now if you want to be a part of it, you don't have to pay anything. You don't have to be even a member of Unacademy. You just need to use Amara code AMB10. You can write this exam for free and get this 20 lakhs happen. You can start writing even if you are a student starting from 7th to 12th, you can write it. Days and times are given as you can see. What all you're gonna get? Array rank 1 is gonna get MacBook Air, rank 2 to 3 Apple iPhone, 4 to 5 iPad. अरे बाप रे, बहुत सारा prices मिल जाने हैं, so don't miss it. ठीक है? Now as you all know, if you make the subscription right now, you're gonna get कितना? अरे for the first 500 subscribers, you will be given extra 3 months का K12 subscription along with that 10% discount. कैसे? Use कर ले हमारा code. I'll write it here, है ना? AMB10 discount ले ले, isn't it? Okay, so this is the batches that is there for 12th standard. So whichever you want, you can come and join. It will be great. Special classes, these are the amazing features of special classes as you can see. Now thank you so much those who haven't shown some love towards your bhaiya. This is your chance. Okay, मौका दे रहे हैं आप लोगों को. Move your cursor, click on the like button and do let me know that you have enjoyed the class. ठीक है? Okay, किया ना सबने? थोड़ा तो प्यार किया ना? And you can share the class. वो कर ले आप लोगों ने. And share the class with all your friends so that your friends can also come and join the classes. ठीक है? So हम जा रहा हूँ. ठीक है? आपका भैया तो जा रहा है. फिर मिलेंगे चलते चलते. पहले लाइक किया. Happy to learn from you, honey, Shrishti. So हम जा रहे हैं. Bye bye. Good night. See you all on Monday at 10 p.m. There is a class for 11th standard. So at 10 p.m. Anyway, bye bye. Thank you.